In earlier videos, we learned about some of the principles used in networking. In particular, we learned about layering and encapsulation. In this video, I'm going to tell you about the four-layer model that's used to define the internet. In particular, the application, the transport, the network, and the link layers. And I'm going to tell you how they fit together and what the responsibility of each layer is. Remember that networks are arranged in layers, where each layer provides a well-defined service to the layer above. What layers do is break down the whole process of communication into a useful set of services that can easily be reused by other applications. So for example, in the figure shown here, we have the application as the top layer of the internet model, and the application is the applications that we use every day, like web clients, email, and so on. What the application does is it calls the transport layer through an interface here. And what the transport layer does is ensure that the bytes that the application wants delivered to the other end of the communication are delivered correctly, that any ones that are missing are retransmitted, and that they're delivered in order. So by making this modular with a well-defined interface, each layer can be potentially replaced later by a different version. So for example, if we wanted to take this one out and put in a new one, I'll just call it T star, a new transport layer with the same interface at the top and the same interface at the bottom, we could easily do so. So each layer is essentially providing a nice layer of abstraction above, hiding the details of how the layer does its job. So done right, this can make the design of each layer very simple, because we don't need to worry about the details of the layer below it. So examples of layers could be in the internet model. So let's say that our application at the top was a web application, in which case it's going to use a protocol that we're going to see later called HTTP. You'll recognize this, of course, as the Hypertext Transfer Protocol. And it could be sending a command out, and we're going to see lots of examples of this, like get file. And this is asking the other end to the web server to return the contents of a file to it, like when we download a web page. Below this, the application is going to call the transport layer, and the most common transport layer used in the internet is TCP, which stands for Transmission Control Protocol. What the transport layer is going to do is going to take that get file command here, and it's just going to see it as a stream of bytes, and it's going to send those bytes over to the other end of the communication, and it's going to make sure that those bytes actually do arrive, and that they arrive and are delivered in the correct sequence to the application at the other end. The most common, in fact the required network layer, is IP, or the Internet Protocol. We're all required to use this when we use the Internet. It's the core, the heart of the Internet. Some people call it the thin waist, and we're going to see why that is a little bit later. So the IP layer assembles the bytes into what we will call datagrams. And these are really packets that contain the bytes passed down from the transport layer. And it's going to add an address, the IP address, to tell the network how to deliver that packet to the other end, hop by hop, packet by packet across the internet. But first, before that datagram can even go out onto the wire, we need to put it onto a physical link. And the most common physical link used in the internet is something called Ethernet. There are a whole variety of them, like Wi-Fi and various other kinds of link. But this is going to send Ethernet packets, and Ethernet packets are often called frames. And these contain the Ethernet address, and then finally that Ethernet frame will go out over the link. So we like to say that peer layers communicate. So these four layers that make up the internet model, they're going to communicate with their peer layer at the other end. So in my example here, I've got the client machine on the left, A, and it's going to be running the web application just as we had before. So it's the web client like Safari, Firefox, Chrome, Internet Explorer. And that on computer A is going to use the HTTP protocol at the application layer, and it's going to be communicating with the other end. And so this is going to be using HTTP, and it's going to be sending something like get file. to download the web page, just as before. And the set of ASCII bytes that make up get file are going to be passed down, and then these will be sent across just as before as the byte stream. Okay. So in order for these to be correctly delivered across at the transport layer and then delivered up to the application at the other end by the transport layer, it's going to use the network and the link layer, and these are going to traverse routers along the path. So let's take a look at a couple of routers, and we're going to assume that they go through these routers. Now what the routers are going to do is to process the packets up to the network layer. So we say that the application layer is communicating to its peer, the transport layer is communicating with a byte stream to its peer. The network layer is going to communicate to its peer along here, and then finally there are links, the physical links that connect these together. And as you might have guessed, we're going to use encapsulation at each layer to place the data from one layer into the format that's used by the layer below. And that format is the one that's used to communicate with its peer. For example, to go back to our HTTP example again, when we take those bytes, which were get file name or get file at the top, when this gets passed down to the transport layer, what's going to happen is that those bytes, we can think of them as being encapsulated into a segment, a TCP segment, a set of bytes, which are the ASCII representation, and then there will be the TCP header that will be, I'll just put TCP-H for TCP header. That's that's the TCP frame that is going to be sent to the other end, and that's the format that will be sent out along here. Next, as this goes down to the network layer, this entire TCP segment is going to be encapsulated. So we're going to take everything that's here, and that's all going to be put into the data portion of the IP datagram. And the IP datagram, we're going to add the IP header. I'm just going to put IPH for IP header. And that's going to include the address of where it's going to and the IP address of where it came from. So it'll have B's IP address, that's where it's going, and A's IP address, because that's where it's coming from. And then when we go down to the link layer, we're going to take the whole of this IP datagram, and we're going to take the whole thing, and we're going to put the whole thing in here. It's going to look like data for the Ethernet frame, and then we're going to add I'm just going to write EH, and EH is going to stand for Ethernet header. And then this finally is what gets sent on the wire across to the first router. The first router is going to check the Ethernet address to make sure that it's the Ethernet address of the router. It will then decapsulate. That's what we say. That's what we call it when we take the data out. It's going to take the data out to create the IP datagram. So here's the IP datagram. It's going to check the IP header to make sure that the address is something that it has in its table. And then once it's looked up in its table, it's going to tell it where it's going to send it to next. So it's going to send it down to here, which means it will encapsulate it again into a new Ethernet frame, put a new Ethernet header on it, and send it on its way. Notice that the Ethernet address that it uses is the Ethernet address of the link. So for example, when it's sending it from A to the first router, it's going to put the Ethernet address of the first router. When it comes from this router to the next router, its source Ethernet address will be the Ethernet address of this router, and its destination Ethernet address will be the destination of the next router. On the other hand, the IP address, the address of the datagram that's inside, contains the IP address of the eventual destination B. That allows it to be looked up hop by hop to send it on its way across the internet. Up until now, our link has just been a fixed point-to-point link from A to the first router. In practice, it can be more complicated than this. There might be switches that are between between A and the first router. And the reason for this is that there might be many computers connected to the Ethernet network that the router and A are also connected to. So for example, it might look like this. A might connect to the first switch. The switch might be connected like this one might be connected like this, and then this one finally is connected to the first router. These Ethernet switches are only looking at the Ethernet address. They don't look inside and look at the IP datagram. They're only allowed to look at the Ethernet destination address. So they're making their forwarding decisions based entirely on the Ethernet frame. So that means to the network layer, they're essentially invisible. The link just looks like a link. The IP datagram is passed down to the link, and then the link will make a good effort to send it to the first router without the network layer having any idea how it got there. Finally, our packet is going to reach the other end, and it's going to reach the Ethernet interface of B. So here is our Ethernet frame arriving from, here is its data and here is its header, arriving at B. The link layer is going to check that the Ethernet packet has the correct destination address of B. That's going to be happening here. And then it's going to pass it up to the network layer. And the network layer is going to take out the IP datagram. So remember, we've got the Ethernet frame, and here is our Ethernet frame. It's got its data and its Ethernet header. It's going to take out from here in the data portion. This is going to be a fully contained IP datagram. So it's going to have its own IP data, and then it's going to have its IP header with its IP destination address. So this is the IP datagram. The network layer is going to check that the IP address is the correct one for B, and then it's going to take out the data portion of the IP datagram and pass it up to the TCP layer. So this will be the TCP data, and then the TCP header. It's going to write TH for TCP. And then inside that, it's going to pass up the bytes corresponding to the for the application. And in our case, hopefully these will be get file that will be passed up to the application. So this is the basic operation of the 4 layers of the internet. So it's enough to get us started looking at each layer in detail. So let's just recap what those do. The application layer talks to its peer, just sending commands to its peer. The transport layer will make sure that those bytes are sent correctly, in sequence, and it will retransmit anything that gets lost along the way. It does that by putting them into IP datagrams that are sent through each router along the path, and those routers will check the IP destination address and send it hop by hop, packet by packet, from one end of the internet to the other. As it traverses the internet, it goes link by link, and it does so by being placed in an Ethernet frame, one link at a time, all the way across to the other end. A few last words about the 4-layer internet model. You may have been wondering, where do these different layers run? Well, in modern operating systems, it's very common for the application to be running as a user process in user space, and that the transport layers and below will operate inside the operating system. And there's a well-defined API on almost any operating system that you would use called the socket API, which is used by the application process in order to call upon the network stack that's running inside the operating system. Many of you may have used the socket API when creating network applications. Another question you might have is, why is the network layer often called layer 3? If you look at the 4-layer internet model on the right-hand side, the network layer is the second layer up from the bottom. So why is it called layer 3? Well, there used to be a different layer model that was very widely used called the 7-layer OSI model, and OSI stands for Open Systems Interconnect. It was created by a standards body in the 1980s, and you'll still find it very widely described in textbooks. And in this particular model, it was broken down into seven layers in order to try and create a more generic model that could be used for many, many different types of network. In some ways, that's become moot these days because the internet so dominates modern networking that the simpler 4-layer internet model is much more widely used instead. However, the 7-layer OSI model lives on in this numbering scheme, and it sometimes gets a little bit confusing. So the physical layer was layer 1, the link layer was layer 2, the network layer was layer 3, transport was 4, session was 5, presentation was 6, and application was 7. The ones that you'll hear most commonly used today are the physical layer, and that's used to describe anything to do with wires and connectors. The link layer, which is what's usually referred to as the Ethernet layer. The network layer is layer 3. Transport layer is layer 4, all the way up to the application. These are the ones that you'll hear most commonly. 1, 2, 3, sometimes you'll hear 4 as the transport layer, and 7. So it's worth knowing what they are. There's a fairly straightforward correspondence between the 7-layer OSI model and the 4-layer internet model as mapped out here. What we've been referring to as the link layer in the internet model was actually represented by 2 layers in the 7-layer model. The link, which is all of the protocol, the formats, and then the physical layer was things like what the wire is made of, what the connectors are made of, what the signaling levels are that are used on the wire. The network layer is the same in both. In the 7-layer model, the transport was broken down into the session, which was to do with how communication was established, how a connection was established from one end to the other, and then transport, which is all of the other things to do with reliable in-order delivery. The application layer was broken into 2. The presentation was the format in which the bytes were presented, for example, ASCII or binary, and then the application, which is the way in which those bytes are used. So for example, in HTTP, get file would be an example of an application command. That's the end of this video on the 4-layer internet model.